In this tutorial, we will be focusing on the proper way to structure a table. You can go ahead and create a table, but there's a proper way to actually do it. It's not just about putting data into table to form a database. There's actually a process to constructing your table. So what is a proper table structure? How does a proper table structure feels or look like? Table structure refers to how data is organized within your database. A well-structured table allows for efficient querying, updating, and also ensure the relationships between different data sets are preserved. This involves identifying entities, attributes, and relationships. Okay, I've mentioned quite a lot of jargons there. So I mentioned entities, attributes, and relationships. These three things are keywords, and I need to explain them. Entity represents real-world objects or concepts, e.g. customers, products, schools, teacher, or vendor. Just imagine it, whatever application you are building, you will deal with entity. These are the things that interact with your application. What are attributes? Attributes are more like the properties of those entities. Like the customer, product, schools, teacher, vendor we talked about, they will have one form of attributes or the other. For example, name, email, price, and title. And the last thing I did mention is relationship. So relationship define how entities are related to each other. So we can say customers can purchase multiple products. So you can see the relationship there. There's a relationship between the customer and the products. Customer buys products. Teacher can take multiple classes, or you can assign a teacher to a particular student. Whatever kind of relationship you want to build with your entity is up to you, depending on what solution you're trying to build. What is normalization? Normalization is a process used in database design to organize data into tables and reduce redundancy. So what normalization brings to the table is to make sure that there are no repetition across what it is that we are doing. So normalization involves breaking down large complex tables into smaller, simpler ones without losing any critical information. So one important thing you need to note in the normalization process is that they typically follow a series of steps, each building on previous known normal form that we must have covered. And there are quite a lot of forms, but we'll be focusing on three forms, and they are called first normal form, which is denoted by 1NF, second normal form, third normal form, and like that. But we're going to stop at 3 normal form for your level. So it's pretty simple. Don't worry, we're going to get into practical and then you're going to see how it works. But before we get into the practical session, we need to give ourselves an example and see how we can apply table structure and normalization into what we are talking about. So imagine a retail business that sells electronics. So let's look at a typical order management system. You might start with a table called orders that contains all the information about each order, including the item purchased, quantity, and price. From these, we can pick out orders as being the entity, and then quantity, price, and item purchased can then be the attributes. Don't worry about relationship for now. We'll get into that later. So this is normal table structure. We've not done anything to it. We have the order table that has customer name, order date, product name, quantity, and price per unit that you want each of the items to be purchased at. You can see the entry. The first customer is John Doe, and the purchase date is there. The item is purchasing. You can see that he's purchasing 2 items, and the first item happens to be like quantity 1, laptop 1, laptop 2, mouse, and you can see the price of the laptop is $1,000 and the mouse is $25. So I won't go ahead and read the rest, but from here you can begin to get the sense of what is happening. We have 3 records or 3 orders, right? But this is not well optimized in terms of how you are supposed to be storing data. It's not just enough that you could create a table. You should be able to structure data the way it should go. How can we normalize this table? How can we get it into a proper form? We start with what? The first normal form. Then we go to the next forms like that. So let's start and let's see what the first normal form is all about. So a table is said to be in its first normal form when all the columns contains atomic indivisible value. that is the definition. But let me explain what that atomic stop is all about. So instead of listing multiple products like this in a single line and also listing multiple quantity in a single item, you need to be able to allow individual data to have its own row. So that's what that means. In one cell, we make sure that each product gets its own row with only one product per row. That is the meaning of what first form is all about. Based on what we have in the first record, we can transform that and make sure our record looks like this by making sure our laptop and our mouse creates or has its own row. But by doing so, we've introduced some duplicates in the system, which for now is okay. So what do we mean by duplicates? Number one, remember that the John Doe, which is order number 1, has purchased laptop. That's one order. Still in the same document, he also purchased a mouse. So we need to create it to have a single record like this. So if you look at this first item, this is one transaction. The second transaction, notice that it's still carrying order 1 and still John Doe, but this time around the product is different, which is mouse, and then quantity 2, 25. This alone, what you've done here by splitting it into 2, you've turned it to what? 1F form. That's first normal form. And you will notice we've gone ahead to split the rest. So this is what makes your data in its first normal form. And you're not done. Remember, we're going to 3 forms. So what is the second normal form? Remember what normalization is all about. We need to build on the current or on the existing model to keep going continuously until you've treated your table to all the forms that you can take it to. To take this current table to second normal form, it must already be in one normal form, which it is now. So it is like the process or the procedure that you must follow to achieve normal forms. So you need to ensure all non-key columns are fully dependent on what? On the primary key. Like for example, the customer name and the order date, product name, etc. depends on the whole primary key, not just part of it. I will give an example. So since we have a composite primary key consisting of order ID and product name, but customer name and order date field depends only on order ID but not on product name, this creates a partial dependency which violates second normal form. To resolve this issue, we can split the table into 2 separate tables. One table that contains information about the order, and the other one contains information about the products in each order. So let's go to the first table and let's see what it is we're talking about. You can see that the items are not depending on each other. So the taking it to the second normal form is splitting the data into their respective tables. So let's see the first table, the order table. So I'm going to call it order table, even though we call the whole thing order, but I'm going to call this one the order table. This table holds the information related to the orders, e.g. the order ID, the customer, and the order date, which is independent of the products. The order you made, even though it's tied to the product, but it's independent, we can actually hold those information separate from the product. So the customer buys a product, so the order can be on its own, then the products can be by themselves. So if we isolate that, we are left with this. We have the 3 orders that we have: John Doe, John Smith, John Doe. Remember, John Doe bought another item another day. Okay, then the next thing is the second part of the order, which is the order items or the products that the person bought. But this time around, we'll give it a name called order items, which is product level data. This table holds the information relating to the products in each order, which will contain order ID, product name, quantity, and also price per unit. The table will also look like so. Now notice what is different, or what is common, what is similar between these 2 tables. What they have in common is what? Order ID. You need to be able to create a relationship between the first table and the second table. Remember that you splitted them up, to form 2 things. So what is the binding glue for these 2 tables is the order ID, and these then become the foreign key, which we'll have more discussions in the next class. This order ID becomes the foreign key in this table. each table should have a unique key that uniquely identifies. You know, I keep saying that a lot. Each table should have a key that uniquely identifies it. So in this case, this order ID is a foreign key. We'll talk about foreign key later. So what key can uniquely identify this particular table? We can call it order. Since we call the table order item, we can call it order item ID. Look at the primary key here, and it's uniquely identifying each record. This is the foreign key, but in this case, it's a primary key here. Okay, let's move on to more explanation about this table. So table 1, like I said, contains the information about the order itself, and there's no partial dependency here. Each order has a customer and one order date. So customer name and order date depend only on order ID. The table 2, which is the order items, this table contains the product details for each of the order. The product name, quantity, and price per unit depend on the combination of order ID and product name, ensuring no partial dependencies. This makes the table in a second normal form, and it makes it second normal form compliant. Finally, we go to the third normal form. What's the third normal form about? To move the table from second normal form to third normal form, we need to eliminate any transitive dependencies. What does that mean? That means no one key attribute should depend on another non-key attribute. Each non-key attribute must depend only on the primary key. So step to normalize to 3 normal form. Identify transitive dependencies. In the current order table, customer name is not directly related to the order ID itself. Instead, it relates to the specific customer. This creates a transitive dependency because customer name can be stored separately in a customer table. So we need to create customer table. We need to move the customer name to a separate table called customers and link it to order using a customer ID. This eliminates the transitive dependencies. So how do we do that? Very simple. We need to create a new table, and we'll call it customers. Store customer information inside there. How many customers do we have in the order? If you look at the order table, we only have 2 customers. So we can go ahead and create customer ID, customer name, add the ID, and then we can create, the customer information there. Now let's now update the order table. Only the order ID, customer ID, and order date remains, as customer name has been moved to the customer table. So our table should look like this now. In this case, we have our data or our table in the third normal form. The next one is order items table. This table remains unchanged from second normal form, storing the product specific information for each order. So here too, we don't have any things to worry about. Everything looks okay. However, we can also change this to a third normal form. The same thing we did to customer. We can have our products in a separate table, because you can have repeated products. Like for example, we have this mouse repeated more than once. So this mouse can actually be in a different table entirely. This becomes our products. So laptop happens to be 1, mouse is 2, monitor is 3, keyboard is 4, laptop USB is 5, laptop bag is 6, the mouse is already repeated, which is 2. So this then becomes in its third normal form. There's an assignment I want to give you guys, and that is database normalization in school management. So to understand and apply the concept of database normalization by designing a relational database for a school management system, the goal is to transform data into its first normal form, second normal form, and third normal form while ensuring efficiency and consistency. The scenario is that you have been hired to design a relational database for a school management system. The system needs to manage data related to students, courses, teachers, and enrollment. Your task is simple: to normalize data to reduce redundancy and ensure that the database adheres to first normal form, second normal form, and third normal form standard. So this is the data you are presented with. Good luck, guys. So to build a table just like I have done in VS Code, you need to get a Markdown, and by default VS Code comes with Markdown, and the extension for Markdown is .md. So I can just create a text file like this, .md. Remember the extension MD, and I can go ahead and start creating tables just for it to be easy for me to preview or to look at and also to present, just the way I presented to you guys. So how do you start? You start with vertical bar like so, to denote like you are creating a horizontal line. You know, table are in like boxes also, they're in table, rows and column. So you create this vertical bar and then you put the column name. So let's say we're starting with the first column, column 1, and then you end it with that same vertical bar. So this kind of put it in a box, but you know a header has like this underlining thing going for it. So you come down and let's add the second column. So we'll call it column 2. And what do you do next? You put the second bar as well. So notice what's happening here. You have the first bar, second bar, third bar. So each of the content in your table, you make sure that it's grouped or is placed inside a bar. So let's go to the next line. The next line kind of creates an underline, effect. So how do you do that? Always bring in your bar to start. Then you put a dash, 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 dash. You can keep putting it until you have a sizable number. You can just stop at 1. The first dash, and make sure you end with a bar. So if you save this, it just works and it fixes that for you. But you could do this manually, but you don't have to do it manually. Once you just do it once, it knows what you are trying to do, and then it kind of completes it for you. So you could end up doing it manually like this, and then you stop. But if you get something wrong, maybe you stop here like this, it's gonna fill it up for you and do it like this. The next thing you want to do is to pull in data. How do you pull in data? The same way you added your column is the same way you're going to pull in your data. So I start with my vertical bar, and then I say 1, and then close my bar. And the other content is, you can use space, but that's just wasting time. You can just go ahead and put the content. It will auto adjust the space for you. So I can say this data 1, and you can go on doing your manual spacing, but you don't need to do that. Once you just put the vertical bar, it will know that you are done with that content, and it will try and adjust it for you. So let's go with 2 dash and then say data 2, and then I close it, then I just save. So you could see what I was trying to say. So it makes it faster. If you want to add a new column in the middle, I'll just say in the middle, and I need to do this. So this denotes that I want to do that, and you know that you are left with completing this part. So I will do this like this. I don't have to put it in full. You know that this data 1, data 2 belongs to this column 2. So I'll just kind of create a space here by doing like this, and a space here by doing like this. If I save now, these will now fall under this section, so allowing me to populate this section. So this is very good for visual effects. So this is Markdown, and it's good for presentation. Thank you for staying to the end. Don't forget to like, share, subscribe, and turn on the bell notification for more videos from us. See you in the next one.